Hi, sixth graders. This is part 3 of your 1.3 notes on forces. This is the part that is highlighted in green, and it is on Newton's laws. All right. So Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion and moving at the same speed and direction unless it experiences an unbalanced force. Okay, so let's watch the video.
Hey, can you give me a hand?
Nah,
Oh, RJ, this sofa's heavy. Can you help me move it?
I'm reading something. Can't we do it later?
Man, talk about inertia.
Inertia? What do you mean? I'm just chilling.
More like frozen in place. A perfect example, since inertia has to do with how things move. Or don't. It's Isaac Newton's first law of motion. The first part says that because of inertia, objects in motion will keep moving at the same speed in the same direction.
Forever?
Yep. Unless some force changes their motion.
Come on. How can something keep moving forever?
Well, think about Mia on her scooter. Once she starts rolling, she just keeps on going.
Yeah, until she runs into some gravel or something.
That's because gravel causes friction. It makes her slow down and stop.
Yeah, but she would have stopped eventually.
Not if there wasn't any friction or another force to stop her. That's the most important part of Newton's law. If Mia was zipping along in outer space where there's no friction, once she started moving, she wouldn't need another force or push to keep her moving. She'd just keep going at the same velocity forever.
Velocity? Isn't that like speed?
Well, speed and direction.
Wow. Can you imagine Mia going straight out into space?
Now that would be a trip. Speaking of trips, inertia is what makes you slide sideways when you're riding in a car that makes a sharp turn.
Really?
Oh yeah, when you're driving along, even though you don't feel it, your body's moving as fast and in the same direction as the car. If the car turns fast, your body keeps moving in the direction you were going before the turn. So if you're turning left, you'll slide to the right. See?
That's wild. I think I'm getting it. But what about the sofa? You said it has inertia, but how? It's standing still.
Yeah, and so's the scooter after it stops. Lucky for us, Newton discovered that the same rules work for all objects. So part 2 of Newton's first law says that because of inertia, objects at rest will stay at rest unless a force makes them move.
What kind of force?
Well, Mia can push off with her foot to get enough force to start moving again.
So how come you couldn't make the sofa move?
Well, the heavier things are, the more inertia they have, and the harder it is to make them move.
That sofa is really heavy.
That's why I needed your help?
Yeah, I get you. So let's go over this inertia thing again. I want to be sure I've got it. Newton's first law of motion says that because of inertia, objects in motion will keep moving at the same velocity, that's speed and direction, and objects at rest will stay at rest, unless a force changes things. Friction is one kind of force. It can make a moving object slow down or stop. Heavier objects are harder to move or stop because they have more inertia.
Impressive, RJ. I think you got inertia down.
Thanks. Now, how about I get over it and help you move that heavy thing?
Well, I don't want to force you, but I'd love it.
All right, so that is Newton's first law. So an object will stay at rest. Okay, inertia is the tendency for all objects to resist change. So an object will not move unless a force makes it move. And then the second part, an object in motion will stay in motion. So objects will stay in motion in a straight line unless another outside force acts upon it and stops them. Okay, and on Earth, a lot of times those forces are things like friction or air resistance. But if we were in space and you threw a ball, it would keep going in a straight line at the same speed forever and ever because there's no air resistance to stop it and there's no friction to stop it. Okay, so here is another example of Newton's first law. So the soccer ball will just stay there. It's not going to move unless it's acted on by an unbalanced force like somebody kicking it. Okay, and then it will keep moving unless it's acted upon by an unbalanced force. So something stops it, like the net. Or In the case of soccer, friction from the grass or air resistance from the air. Newton's second law of motion has to do with acceleration, mass, and force. So the law states that the acceleration of an object depends on the mass of the object and the amount of force applied. And for this law, we have a mathematical equation. So force equals mass times acceleration. So let's watch the video.
Look at that ball go! I don't know how you do it.
Just a little luck and a lot of acceleration.
Acceleration? You mean speed?
Nope, acceleration. Speed's just a measure of the distance something travels in a certain amount of time. Acceleration is a change in velocity, both speed and direction.
Oh, I guess that is different.
Definitely. Every time that ball gets knocked by a flipper, takes a sharp turn, or hits a bumper, it either speeds up, slows down, or changes direction. That's acceleration.
Wait, it's accelerating even when it slows down?
Even when the speed is decreasing, it's still acceleration, but you can call it deceleration instead of acceleration.
Whew, that's a lot of speeding up and slowing down. But what about before all that, when the ball's just sitting still?
Well, when an object is at rest, that's partly inertia at work. Inertia is the property of matter which states that an object at rest or moving in a straight line stays that way.
So, does that mean inertia slows things down?
Not at all. Inertia is what keeps things steady, whether they're moving or not. It's the constant speed of an object. What you're thinking of is friction.
What's the difference?
A lot. Friction is a force that works against a moving object, like when you ride your skateboard over gravel on the road, or when the pinball is slowing down as it rubs against the wood on the flat parts. Those are both examples of friction and how it slows things down.
So, if inertia keeps things steady, what gets them moving in the first place?
To get something moving, we need force. To start, the ball is sitting still, waiting to be rocketed into the game.
Waiting for force.
Yeah! The force is a push or pull that causes an object to move, stop, or change direction. When I launch it,
Bam!
I apply an unbalanced force, a force stronger than the one keeping it in place. When an unbalanced force is applied to an object, its velocity changes and acceleration occurs.
Nice! It went from sitting still to full speed ahead in a split second.
Right. When there's an abrupt change in velocity like that, that's when acceleration is at its peak.
And every time it changes direction, that's acceleration too?
You got it.
Whew! Acceleration's quite a ride, but I think you got me up to speed on what's happening here. Acceleration is a change in velocity, the speed and direction of an object. When a force is applied to an object that changes the object's direction or speed, acceleration occurs. And until that change happens, inertia is always at work, keeping an object at rest or moving in a straight line.
Sounds to me like you're all up to speed when it comes to acceleration, Sam. But now it's time to excel where it counts.
All right, so let's look at some examples of how we can use this law, okay? So it says these players train by pushing a massive object. If the player is pushed with a force of 150 newtons and the object has a mass of 75 kilograms, what is the object's acceleration? Okay, 1 newton is equal to 1 kilogram times per meter per second squared. So what we would do here is we would take the force equals mass times acceleration. So let's put a text box in here. Okay, so if we know that force equals mass times acceleration, okay, now for this we're trying to solve for acceleration. So to solve for acceleration here, we need to get rid of the mass right here. So to get rid of that, we just divide both sides by the mass, and we end up with acceleration equals force divided by mass. Okay, see how I did that? Because I divided both sides by the mass. All right, so now I can solve this. So the acceleration here is going to equal the force, which is 150 newtons, divided by the mass, which is 75 kilograms. Okay. And when I divide 150 divided by 75, I get 2. Okay. So this equals 2, I would say, newtons per kilogram. Okay. So that would be my acceleration. Okay. For yours, your problems, you're only going to need to use this basic equation where you might have to do mass times acceleration. This was more of a challenge. All right, let's look at this. And this is an introduction to the third law. This is a fun one, if it plays. There we go.
Here we go.
What do you guys think is going to happen?
Good. Oh.
You shouldn't have walked into that, huh? All right. So Newton's third law of motion says whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. So even if we don't realize that this is happening, okay, all forces act in pairs. There's an action and a reaction force which act in opposite directions. So let's watch this video clip, and then we'll do some practice.
Zoe, watch out!
Ouch!
Hey, are you okay?
Yeah. Oh, hard bench. Guess I wasn't looking.
Now that's what I call action and reaction.
Action and what?
Action and reaction. It's Newton's third law of motion.
What?
You know Isaac Newton, the gravity guy? He realized that for every action, there is an equal and opposite reaction.
Like if I run into you, you run into me at the same time?
Pretty much, but there's more to it. Okay, so when you bumped into me, you applied force or pressure against me.
Yeah, sorry about that.
According to Newton's law, my body pressed back against you with the same force.
Come on.
We both felt the same force because the forces from our bodies pressed in opposite directions.
Yeah, but if we hit with the same force, how come only I got knocked down?
Good question, champ. It's all a question of mass. How much matter is in something? First of all, who has greater mass, you or me?
Is that a trick question? You, obviously.
Well, according to Newton, when two objects with different mass collide, they'll accelerate at different rates,
Accelerate?
change their speed and direction.
So even though their forces are the same, one will accelerate more than the other?
You got it. The object with smaller mass will accelerate more.
Smaller? That would be me. So I fell and you didn't.
Hey, come to think of it, the same thing happened with you and my soccer ball. You hit each other with the same force, but the soccer ball went flying.
I got it now. Because my mass was bigger, the ball accelerated more. How about when a baseball bat hits a ball?
Yep, both objects hit each other with equal force in different directions. The ball goes flying because its mass is smaller. The way the bat is moving when it hits can make the ball go in different directions.
And what happens when two things that are the same mass collide? Like two pool balls?
Well, what do you think?
Well, they hit each other with the same force, and the forces press in different directions, so they have the same acceleration?
Yeah,
Wow, this action and reaction thing is a little complicated, but I think I've got it. Newton's third law says that for every action, there's an equal and opposite reaction. That means that when two things collide, they press with the same force in opposite directions. That's why you and I both felt it when we bumped into each other. And when the objects have different mass, like we do, they'll also have different acceleration. The object with smaller mass, in this case me, will speed up or accelerate more.
and she scores. Now that's what I call a smart reaction.
What can I say? I'm just a genius in full force.
All right. So looking at Newton's third law, here are some examples, okay? So whenever you sit down on a chair, okay, you know that you are pressing down on the chair because you have weight, but the chair is also pushing up against you, and you're pushing against each other with the same force, and that's why the chair doesn't move. Now, if you and 10 of your friends try to sit on the same chair, that chair might end up breaking because you are pushing down with more force than the chair can push up with. Okay. Another example here is if you take a balloon, okay, and fill it up with air and you let go of it, okay, we know that that balloon will sputter and, fly up, okay? And that's because for every action, which is the air rushing out, there has to be a reaction. And because they're moving in opposite directions, the balloon goes up, okay? There's another example with the hammer and a nail. As you pull the hammer back, okay, and hit on the nail, it goes into the wall. So the action is the pressing of the nail in, and the reaction is the hammer flying back. Okay, so we have a lot of examples for Newton's laws, and you are going to be looking at more of those examples in your activity that you're doing with the digital notebook today.